First of all, on behalf of Glenn, Lee, and myself, thank you very much for taking your time to sit with us for this hour and talk a little more in depth about the topic of CICS services, about API strategies, and about what those APIs really do. Because if you really look at it, we can talk about API definition all day long and all the tools that let you create really cool RESTful APIs. But at the end of the day, in your organization, what really matters is what happens on the back of that API. How does it become fulfilled? What is the logic, the data, the stuff, the meat of the matter across that API? And that's really what we're going to focus on here today. And just by introduction, between Glenn and myself, we've probably seen as many CICS integration projects as anyone. So if you have any questions along the way, regardless of whether it necessarily pertains to the things that we work with directly in our companies, please ask. This is SHARE, and it's all about making sure that you go home with the most valuable base of new information to deploy in your organization. I like to start with this slide, and I'm not going to answer it up front, but I'll answer it at the end, and it's the question, who are these people and what in the world are they doing? We will come back to this in a minute, and I assure you it is relevant to our topic today. We at HostBridge began our journey in bringing APIs and the whole concept of services to the CICS community back in 2000. I had just exited my prior company, and my co-founder and I were sitting in San Francisco, California, talking to the chief architect of Delta Dental. And his name was Marshall Gordon. And Marshall said, "Russ, I've got good news and bad news." He goes, I said, "Well, I want the bad news first." He goes, "I'm going to send out an email to everyone on my technology staff. And what this email is going to say is one thing. We are hereby, henceforth and forever, banning screen scraping as a mechanism or methodology for integrating to legacy applications." Now, that was kind of that was okay with me in some respects, because the company that I was exiting from at that time, we had one of the biggest, baddest screen scrapers on the market, right? But it was, in fact, formative for this company, because Scott, Glenn, and I sat at Buca di Beppo in downtown San Francisco that evening with crayons and Italian food, and started trying to design what in the world would that look like, right? A world without screen scraping, integrating to CICS transactions in a way that had greater fidelity and throughput and all the wonderful things you would want for a better integration solution. Well, by the end of the night, we had our little crayon drawing, which turned into a US patent, actually. And that patent turned out to be predicated on some really important IBM technology that they had just added in to transaction server version 1, right? And that was basically, when was that? 1999. 1999. It was called the Link Bridge Interface. And it was the first time ever that IBM had created an API under the covers of CICS that would allow a program to be able to interact with a terminal-oriented application before a 3270 data stream was either expected as input or created as output. So we globbed onto that and just ran through that window with the help of IBM as fast and hard as we could. So at about 2000, this was the state of integration. Now, in fact, HTTP was with us then. REST was an idea, right? It was a white paper, lovely white paper back in 2000. But it wasn't exactly a design pattern that we all, kind of glommed onto and said, by golly, this is goodness. Then along the way, a couple of years later, people said, well, I don't just have terminal-oriented transactions, which has always kind of been our forte. We have COM area programs. And so great, we say, great, that's incremental. IBM had some really great ways within the box and under the covers of CICS to be able to invoke COM area programs as a service. No big deal. Customers said they want it. Customers win at the end of the day. So we added the capability. But still, it was kind of a one-to-one world. And this is a problem. And we're going to come back to that even in 5 slides or 6 slides. But this one-to-one world is that one request comes in and it executes one thing, one artifact, one COM area program, one transaction, and then you get a response. And what happens if that one thing isn't quite enough to be able to satisfy the business requirement? Well, this happens. And you end up with distributed systems sending not just one thing in, they send a whole bunch of stuff in. And we saw our customers doing this in the mid-2000s, and we said, whoa, that is not good. Because not only did it drive up latency, it drove up CPU costs on Z, right? Not a good idea, especially when we have the artifacts that we know we need, whether they're existing transactions or programs or data. We just don't want to have to chatter to get this thing. We want to send one request in and get a nice clean response out. And so we begin to think, well, how do you solve this? We need something running under the covers of CICS that will allow the orchestration of those various elements, the orchestration of things that whose lifespan is measured in milliseconds. How do you do that? Well, it turned out there wasn't really anything to do that. And so we were sitting around the office one day trying to figure out, okay, how are we going to do this? Because we see our customers doing some really crazy things here by just kind of doing all this orchestration from the middle tier into the mainframe, driving up CPU. And so we, after eliminating a bunch of solutions, and I have to confess, first of all, at our office, we're a bunch of geeks. I mean, we love nothing better than to kind of look 5 or 10 years down the road and see what's coming and figuring out how we can make that relevant to the mainframe world, to the CICS world. So right about mid-2000s, JavaScript was really starting to grow. We didn't, actually back then, it wasn't even called JavaScript. It was called ECMAScript, which of course sounded like a disease that one could contract if they weren't careful in social circumstances. But JavaScript was out there, and we decided that JavaScript was perfect for any number of reasons to be able to use as a foundation for integration, right? Because it's typeless, it has all these very high-level object-oriented operators. Anyone can learn it, and lo and behold, it turned out that we were right. I can't say I've been this right about many things, but this one we actually got right. And that is that we now live in a world where not only is CICS officially a multi-language application server, but JavaScript is the most popular programming language on the planet. 6-year-olds in my community are being taught how to hack out JavaScript and make little bouncing baloney on a web page. I mean, this is everywhere. And we have customers and employees and contractors writing services for CICS who would not know a mainframe if they were in the same room. And we sort of like that. We kind of like the idea that they create services for platforms they don't even know what they look like. But we did it for a very particular reason. Now, we made a conscious choice not to use a kind of a modeling or diagramming approach. When Glenn talks about his product, they did. And there's nothing wrong, right? It's a horses for courses thing. We made our choice just based upon the guidance of our customers, no differently than I'm sure they did based upon their guidance of their kind of original customer set. We did ours, however, we camped on JavaScript because we were betting on it as a long-term technology. But secondly, we thought it was right based upon the complexity of the problem that customers were presenting to us. Fairly complex things. If you ever have a chance, not that you would, to look at the U.S. Postal Service's payroll processing program, you will learn a new definition for complexity. It cannot be modeled. It cannot be diagrammed. It can only, you have to understand it as a body of COBOL program that has evolved over a long period of time, and to integrate to and with its functionality requires specificity. It requires detail. And so that's really why we took the integration approach that we did. Okay, so now we're out there, helping customers build these services, and this was 12 years ago. And this was really cool. In fact, we invented and coined the term microflows and microservices for CICS. But customers, being what they are never quite satisfied. So they said, as soon as IBM came out with the zip engine on Z, guess what everyone wanted? That's right, they want zip enablement. And so fortunately, IBM created a program where we ISVs can participate as long as we abide by certain legal standards to offer our products running on specialty engines like Zip. So that was the next thing that we did. And thanks to IBM and our work with them and Poughkeepsie, the lab there, we were able to do that. So along the way, we gathered a bunch of customers up, and they began to put to us even more requirements. Now, here we are. Let's fast forward today. And we just heard a great presentation about a tool like ZOS Connect. We live in a world where tools in and around APIs are now becoming very prominent and popular. To facilitate the API, to map the API, to manage the API. Lots of great tools are coming up. But I want to draw your attention back to the issue of how you map, manage, or define the API for most of our customers, most CICS customers, is not the first issue to consider. The first issue is, in what shape or form are your existing business assets? Now, ZOS Connect makes an assumption, and that is, for the most part, that when a request comes in, it has this wonderful tool, and I love it. I can map everything across. I can take a JSON document. I can play all sorts of games and bring it over to a COM area type structure. And then I can invoke a COM area program, and I can do the reverse on the way out. Way cool. Way cool. The only problem is, what if the service you wish to implement is not or cannot be fully embodied by a single program? That's the oops moment. Right? Got to change the program, embellish the program, do different things. Or you're going to end up here. And we saw this slide 12 years ago, where if the form of the business logic, its expression within CICS, does not really, we might be able to map the API, but if it doesn't map the logic, the business logic that the distributed system really wants to invoke, you're going to end up here. Lots of requests going back and forth. Now, maybe in some organizations that might not be a problem if their volume is low enough. But if you have a high volume situation, just be careful. And that's where we think products like ours or other integration approaches on the mainframe fit in. Because at the end of the day, we are not about API mapping. We like to say we're about API fulfillment, about being able to take your desire to express a service and be able to embody that service through multiple artifacts. Maybe you have to really go hit a couple of terminal-oriented transactions to look up an account number. Maybe you got to go fire off a couple of COM area programs. And maybe you need to go out directly to vSAN, DB2, Datacom, whatever, we don't care. And be able to gather that all up in a matter of, maybe 100 milliseconds, and be able to yield a composite response going back out to, let's say, your distributed banking platform. So again, the point of this slide is that always keep in your mind the difference between API mapping and what is really going to fulfill the API on the interior side of CICS. It's sort of like the difference like this. Now, first of all, I really like this slide only because I found that there is a person who wrote a book called What on Earth is a Mainframe? Has anyone ever ordered that book? Really? You're the first person who's ever raised their hand when I asked that question. So there is a book, in case we're all wondering. But it's sort of like this, right? You think you're doing one transaction to Amazon or whatever. But in reality, there is a whole lot of work that goes into request fulfillment. What we do, we don't focus on the stuff on the left. We focus on the dirty details on the right. How do you fulfill a request that says, yes, I want a customer's account, but in order to fulfill that request requires that you do multiple things far beyond executing a single COM area program. So in 2018, where our customers are guiding us, just to kind of say, they seem to be very pleased with the general orientation with our deployment of services, but now they're wanting to bring the deployment of those services to the corporate dashboard. And in many organizations, the so-called corporate performance dashboard is managed by something called a product like Splunk. A product that is more formally called an SEIM platform. Splunk is probably the leading candidate here. How many, just out of curiosity, how many of you have heard the word Splunk? There's a thing called Splunk that exists. Great. Hands down. How many of you know, without a shadow of a doubt, that your organizations, someone in your organization actually uses Splunk for something, just anything? How many of you know? Okay, interesting. Well, Splunk is out there and they're doing a fantastic job. They're not the only. Elastic is out there. Lots of other things are out there. But one of the things that our customers said is what's killing us is the fact that CICS is not on the radar screen. All these network stuff, all this, CICS is not there. So what we invented most recently was what we call the CICS Transaction Analytics Connector. And what this is we work in conjunction with a tremendous feature in IBM Transaction Server 4.1 or so and later called CICS Transaction Tracking. Incredible feature. There are only a couple of deficiencies, such as one of them being how can you correlate things that go on in the outside world with the CICS activity on the inside world. So the Transaction Analytics Connector is a targeted strike to be able to bond those two worlds together. You see that I have this little diagram that goes out to Splunk. There are various ways to move data out to Splunk. We provide a simple one with the Analytics Connector, but there are others from a number of different vendors. For example, SyncSort IronStream does a bang-up job of sending things down. IBM has various tools to be able to move data down to these analytics platforms. Our job is very simple, and that is to augment transaction tracking to make sure that CICS and all CICS transactions are on the Splunk, or more properly, the SEIM radar screen. So, I owe you an answer to one question. Who are these people and what are they doing? And these are COBOL programmers in Bangkok. These pictures were taken about 5 months ago, and they are creating API-based services. They're kind of doing a hackathon. They're creating API-based services from their COBOL apps. I'm happy they're using HostBridge, but really what's more important is that they love the experience. You can tell these people, they are COBOL programmers. They are in the age group prior to mine, let's just say, and they are in fact using CICS to deploy modern API-based services for one of the largest banks in Thailand. Thank you.